Welcome back. I just wanted to say that someone had asked me again for the IntelliJ. Yes, you, sir. What's your name, please? Say it louder, please. Surya. Yes, Surya over there asked me for the IntelliJ serial number. And so what I thought I would do, since it was buried in a homework that's no longer visible, is I would send it in an email to everyone so that you could have it. The username, not only must it be spelt correctly, but the first letter, Fairfield, must be capitalized, and the U in university must be capitalized, and everything else must be lowercase, and there must be a space. You have to type it precisely, because what they do is they take the string and they map it to this gobbledygook that follows. And so when you type in the gobbledygook license key, somehow it matches to the string, making a kind of a security code out of it. So spelling and format count when you put in the username. So I'm sending that out to everyone in case you needed it. So now you can download the full version. There are two versions, you know. One is called the Community Edition, for which you do not need a license. And the other is called the Enterprise Edition, which gives you all the different interesting and wonderful features. And that's the one I think you would like. Is there anybody here who had some trouble with IntelliJ? Or had some questions about IntelliJ? I also, prior to the beginning of class, I sent out an email for a homework 4, which will be due on Wednesday. And then I also sent out a homework 5, which will be due a week and a half or 2 weeks from now, I guess, in October. So homework 5, that's the one where we worked the problem on the altitude of the weather balloon. So that's one of the questions that's in homework 5. And then I started to embark on chapter 6. But I'm perfectly happy to answer any questions that you might have about homework 5, or even homework 4 on the base conversions. Nobody has any questions? You can sit like lumps on bumps if you want to, but it won't stop me. I'll keep going. So, at the beginning of today's class, we started with a little radix conversion, and we went through all the different exercises. Then we embarked into an understanding of basic classes. We were able to make new instances of classes. We were able to create instance variables in the class instances, and those instance variables only exist at runtime. So a variable like a float p or a float I, that does not get allocated from memory until somebody says new certificate of deposit. Then it goes to the heap, grabs out a little chunk of memory, and transmogrifies it into a certificate of deposit. When you ask for another certificate of deposit, it goes to the heap, transmogrifies that, and says, I have a separate certificate of deposit. When you say, are the two equal? It says, no, these are different. But when you define equality as using equals, and equals says that principal and this principal must be the same, and this interest rate and that interest rate must be the same, then the two are equal. So now let's assume that you want to check equality, but you want to do it for a slightly different interest rate. So now when you go to compute equals, what you'll do is you'll say C2 has a higher interest rate than C1. So C2.I is set equal to, let's say, 4%. Are they going to be equal now? No, right? Because equals requires not only the principal be the same, but that the interest rate be the same. So it should print false, as well as the class name. And that's understandable, right? I don't want to do that. Switch test. Well, I'm going to go through some of these topics in order. I think it's better if I do it in order. So we saw the constructor. Now I think maybe you should discuss a little bit about the accessors. Accessors enable us to change and access or read values. Suppose I said to you, this float has a visibility. The visibility modifier in this float is implicit. The implicit visibility of the modifier is known as default visibility. That is to say, you didn't set it, therefore it has the default visibility. Default visibility is going to enable other classes within the package to have access to the value for the float P or for the float I. However, if you make this private, then in effect the only classes that will have access to float P will be those that are inside of the class that has defined it. So if I make float P and float I private, since the only classes that are making access to it or reference to it are inside of the class, everything will run as normal, just as before. Nothing changes. That's interesting. So if nothing changes, a difference that makes no difference is no difference. Nothing changes. It all works fine. Useless. Who needs it? Garbage. But if I create a new class, here's one called, well, I'll make a new one. I'll make one from scratch. I'll make a class that contains certificates of deposit. Perhaps we'll call it the portfolio. And in the portfolio class, I have a main method. And in the main method, I have a new instance of a certificate of deposit. And now I would like to have access to the interest rate. This will print the interest rate. I think that'll work. I think everything looks fine. Now suppose I'm a little greedy and I want to increase the interest rate. Well, the bank hasn't given me permission to do it, but I don't care because I know how to program in Java, so I'll do what I want. They say it's not permitted. I say I don't care. I do what I want. C.I equals, oh wait, it won't let me do it. It won't let me change the interest rate. Why? What is it saying? It says private access. But I'm in the same package, but it won't let me do it. I'm very sad. I want bigger interest, but I cannot get the money. So how would I be able to get the interest? I suppose I just want to read the interest. Let's see now. Float interest equals C.I. Well, I can't even read the interest. So suppose you want to make it so that the interest can be read but cannot be set. In other words, you'd like what's called an accessor. Well, one thing you could do is you could put in what's called a setter. So now what we'll do is we'll add a public method which returns void and is called setI. Takes a float and says I equals F. Now with the setter, I can set the interest rate, but I am not allowed to read it. So I made a write-only variable. This is very interesting. So now I have c.set I, and I can set it to whatever I like. Ooh, I'm going to make 10%. Haha, I win. And now when I print, it should tell me the value of the interest rate at 10. That's great. 10% interest. Wow. I'm sitting pretty here with 10% interest. That's terrific. But suppose I want to do a computation with the interest rate. Well, let's see now. Float I equals c dot get I. I can't get I. There's no getter. C dot I. Can I do that? No, it's private. So if I can create a setter, perhaps I can also create a getter. These are called, the accessor and the mutator. The mutator changes the value, and the accessor gets the value. So now what I'd like to do is get I, return something of type float, and I will spell it correctly, and then I think maybe you can return I. There. So now I have both a setter and a getter, which means I have both a mutator and an accessor, which means I have the right to both change and read the variable, even if I am outside of the package, and certainly if I'm outside of the class. So now I'm in the portfolio. I still can't do c.I. I still can't get to it directly. But I could control how I get to it by doing get I, and this will give me the value. And now I can set I, and now I can say, here, I better set it before I get it, right? Otherwise I'm going to be getting an old value. So we'll set it first, then we'll get it. We'll print out C, and just for jollies, we'll also print out I. So what do you think of that? I've got setters, I've got getters. I can make variables read-only, I can make them write-only, or I can do both. When you printed this value, system, this part, oh yeah, it printed. Okay. I was thinking it should have printed last. There. So what else do we got? Good. Okay. So now let's assume that I would like to have a new kind of certificate of deposit. Well, I see the class certificate of deposit has a fixed interest rate. What if I had a certificate of deposit that had a non-fixed interest rate? Suppose I had a certificate of deposit that was just like a normal certificate of deposit, but with a difference. And the difference is it knows its date. So I'd like to borrow from the principal, the P variable, borrow from the interest, the I variable, borrow the setter for I, borrow the getter for I, reuse all of these things, and make a new kind of certificate. This one knows about the date because it has a floating interest rate. So this new kind of certificate can be created and we'll call it a floating certificate of deposit. And it is just like a certificate of deposit with a difference, and the difference is it has a date. Because it is a kind of certificate of deposit, I can say that it extends a certificate of deposit. Extends. So the floating certificate of deposit is a kind of certificate of deposit. Inherits from its superclass, certificate of deposit, the property P for principal and the property I for interest. And so what this means to me, the programmer, is when you print it, it will also inherit the toString method. And that means it should be able to know how to print itself. And it does. Very interesting. Its behavior is now a function of its superclass. Suppose you got rid of the extends. Because its behavior is a function of its superclass, by removing extends, I would expect its behavior to change. That is a perfectly reasonable expectation. Now he has completely different behavior. Moreover, if you subclass the superclass, but there's something about the superclass's methods for converting to a string that you don't like, you can override or shadow those methods. So, in effect, if you said to me, gee, I don't think certificates of deposit that are float should print the same way that a certificate of deposit that is fixed prints. And the reason why is because they need the date. I can add a new private variable called date D and set it equal to a new date. Now Java says, what date did you mean? I got an SQL date, I got a java.util date, you want dates, I got dates. And he says with this pop-up, java.util date, multiple choices, Alt Enter. And this will allow you to choose which of the date classes you want. Disambiguating the identifier date is only possible if you have a fully qualified class name, which includes the packages. Alt Enter allows a pop-up which lets you pick which of the date classes you meant. There's one here from Sun, there's one from SQL, there's one from a place called Saxon. I just want the Java util date. That's the common date. And now, this doesn't really print the date. It only prints the principal and the interest. But I still want the date. So to override how toString works, I can do the following. Public string toString. Now, I like the idea of getting the principal and the interest, but I also like the idea of having the date. So when I return, I will return the date, D, plus, I would like to go to the superclass, super dot to string. So what is happening here is I went to the certificate of deposit from the floating certificate of deposit, grabbed the toString method, invoked the toString method in order to be able to get the principal and the interest rate, then concatenated it on to the current date, or at least the date at which it was instanced. That won't change as long as the class is alive. And then I printed out both the date and the principal and the interest. How exciting. So the toString method in the floating point certificate of deposit is said to shadow the toString method of the superclass. But it has also borrowed the toString method's invocation in order to be able to grab onto that information and not have to repeat it. So I've reused a certain chunk of that code. And now floating points certificates print differently from fixed certificates. How do I know if that's true? Well, let's print out the floating certificate of deposit, and then what we'll do is we'll print out a regular certificate of deposit. And now I think we'll see it's printing two completely different things. One with date, principal, and interest, the other with just principal and interest. And certainly we can see that it has reused and left, I'll call it synchronized, the principal and interest, but even the small thing that, well, yeah, it's been set consistently, it's become, I would say, supplemented by the date. So now suppose you wanted to compare these two things. Are they equal? Well, let's find out. Let's get a variable floating certificate of deposit FCP, floating certificate of deposit, and we'll also do a certificate of deposit. Looks like I've got a problem. There we go. So now we'll put in the certificate of deposit. So is FCP equal to CD? You tell me. Boolean B equals FCP equals CD. Are they equals in that sense? Who thinks they're equal? Nobody? Really? But one's a superclass and the other's a subclass. Shouldn't they be equal? No. Why? Because they're different instances. Right? So that's false. They're not equal. But wait. What about equals? Can't the equals compare the fixed certificate of deposit with the floating certificate of deposit? Shouldn't they be equal? How does equals work? Well, it just compares the principal and the interest. It doesn't matter that there's a date. As long as the principal and the interest are the same, they're said to be equal. So it comes back as true. Now, it may be the case that after a time, the floating certificate of deposit will change because its rate of return changes, at which point they will no longer be equal. But for now, they're equal. What do you think of that? So here, floating certificate of deposits in action. Ooh, how exciting. FCP.set I. Let's set the interest rate to 10. Ooh, now they're not equal. Right? Because it just floated to 10%. So now we should see the Boolean printout as false. And so it does. So that's working. So now I've got a subclass, the floating certificate of deposit, a superclass, a certificate of deposit. And in fact, both classes have something in common. Both classes reside in the same file. And the two classes are just like one another, but there's a visibility difference. One has default visibility for the class, and the other is public. Suppose you wanted the floating certificate of deposit to be public. Is that a syntax error to declare it as public? No? Yes? Maybe? Let's find out. So we make it public, and it says, oh, he doesn't like it. Why not? Well, he gives me a little red light bulb over here, and he says, make it not public. What's that about? I want it public. He gives me an argument. Stupid computer arguing with me. He says, oh, move class floating certificate of deposit to float certificate of deposit.java. Well, let's try that. So now what has he done? He made his own file called float certificate of deposit.java because it's public, and had it reside in its own file because the bytecodes will now reside in their own file inside the package, which means the Java virtual machine will be able to find them. So what this enables me to do is use the file system and IntelliJ in order to help organize my public classes. Sweet. In all other respects, it should behave the same. And let's see if that's true. At least there's no red spots. So it's cold in here, isn't it? Is no one else cold? I'm the only one. So what do you think of that? We've got classes now, we've got reference data types, we've got superclasses, we've got subclasses. We've had constructors, we've done shadowing, we've done public, we've done private, we've organized our classes into individual files. In fact, today we did quite a lot. And that was all after we did our radix conversions. Did I do too much, too fast? Yes? You're going like this. Does that mean yes? Yes? Wait, what can I do to review some of these things so that they're not... you want another example? I think there's nothing more annoying than a good example. I can do another example. Let's see. I think I might even have one here in the class. Oh, I see. Yep. It's a dumb example. I don't like this. This is the one about the lamp and the mammals. Okay. Here's my little portfolio. I'm going to introduce you to a new reserved word in Java. Boolean B equals C. Oh, I know how to do this. Got it. Let's make a floating point instance of, or a floating point certificate of deposit. We'll make an instance of a floating point certificate of deposit. Let's say it right. Float certificate of deposit. FCP P equals new float certificate of deposit. It needs to be spelled properly. There we go. Now we'll see. Is a float certificate of deposit an instance of a certificate of deposit? Enter. B equals end quote plus B. Instance of. That means we made an instance of a certificate of deposit in order to get the floating point certificate of deposit. But one thing I noticed is a floating interest rate, a floating certificate of deposit is not the same as an instance of a certificate of deposit. Not the same, right? Because one is a subclass and the other is the superclass. So should instance of return true or should it return false? Anyone want to hazard a guess before I try this? I think it's going to return true. Why? Why should it return true? Why is that? It's much more important that you go through the process of deciding why than just finding out the answer. The reason why is because instance of reflects the dynamic ability to cast a subclass into a superclass without telling the compiler that you have to explicitly cast these two things. Subclasses always cast automatically to superclasses. Why? Why is that? Because it's classification. Class stands for classification. So if the superclass is human and the subclass is, let's say, professor, a professor is a kind of a human. So if you want to say, is a professor a kind of a human? The answer is yes, usually. If you want to say, well, a human was subclassed from mammal, and you want to ask, is a human a kind of a mammal? The answer is yes, usually. So when you say instance of, if you're trying to find out if a human is an instance of a mammal, the answer is yes. But let's go the other way. Oh, does it work the other way? Can we say Boolean B2 equals, is a certificate of deposit an instance of a floating certificate of deposit? And the answer is no, right? Because certificate of deposit is not an instance at all. It's a class. How about this? How about we make a class and we call it certificate of deposit? Oh, we already have one. It's called C. So is C an instance of a floating certificate of deposit. C, remember, that's the superclass. So now let's print out B2. So C is equal to a certificate of deposit. It's the superclass. It's not the subclass. So that doesn't instance, right? In other words, why? Because a human is a kind of mammal, but a mammal is not a kind of human, right? Why? Because the subclass is a kind of the superclass. And in an AKO hierarchy system, a kind of hierarchies mean the subclasses can automatically cast to the superclasses, but the superclasses cannot automatically cast to the subclasses, right? Because the superclasses have all the properties and all the methods that the subclasses inherited, but then the subclasses inherited those properties and methods and then added their own. Remember, when we looked at the subclass of the certificate of deposit and we saw that there was a floating interest rate certificate of deposit, it added its own property. It added its own date. The compiler has no way to transmogrify a fixed rate certificate of deposit into a floating rate certificate of deposit automatically. That's not an easy transform. Right? Compiler doesn't know how to do that. You have to write a program for that. So to have the casting happen automatically from subclass to superclass, that you can do. But to go from superclass to subclass, you can't cast automatically. You've got to do something in a program that's going to add those extra properties. How's that grab you? Sweet, right? So instance of reflects casting capabilities, which means that if I have a certificate of deposit superclass called D, I can automatically set it to the subclass floating certificate of deposit. And the compiler is totally fine with that because instance of works. Right? Instance of an FCP is an instance of a certificate of deposit. Therefore, the setting will work without an explicit cast operation. If, on the other hand, you said to me, well, what I really want is a floating point certificate of deposit, and I want to extract it from my regular certificate of deposit, I got a problem. He won't let me do it. Stupid Java won't let me do it. But I'm clever. Aha, clever programmer. So I will cast it myself. Floating certificate of deposit. So there, I win. I win. I win. I did what I want. I do what I want. So, and the compiler lets me. See, no error. It's fine. It likes this. So that's good. I win. I have an answer. So let's run it now. What could possibly happen that could go wrong? What could go wrong? Will anything go wrong? Could this work? I took a certificate of deposit and I cast it to its... Wait. Class cast exception at runtime. What the heck is this? It doesn't work. I fooled the compiler, but I couldn't fool the runtime. So who's the fool now? Well, as it happens, I was able to tell the compiler, I know what I'm doing, trust me. But the compiler said, okay, I will trust you. But the runtime said, I'm sorry, this doesn't fly. I do not know how to do this. I cannot go from the superclass to the subclass at runtime automatically. Now, if you want to do that, if you think, gee, I really want to convert certificates of deposit into floating rate certificates of deposit, you can do that. How would you do that? How would you make that work? Well, you make a new instance of a floating certificate of deposit from the existing certificate of deposit. And in doing so, you have to create a new constructor. And the new constructor takes a certificate of deposit, takes the principal, takes the interest rate, and then sets it. So it says set I, your local interest rate, to C dot get I. That is, you copy the interest rate. Similarly, if there was a setter for principal, you would do set P. Or you could say P dot, let's see, P equals, I think it's private, but superclasses, yeah, subclasses can't gain access to the private superclass variables. So you need a setter. So you'd have to have a setter, or you'd have to make this public, or you could leave it default visibility. If you wanted to, you can find a way to do this in a fairly automatic fashion. Refactor, and then it should be possible to encapsulate the fields, and then go to P, and it will automatically create get P and set P. Give the accessors public visibility, refactor, and voila. Get P and set P were automatically created. Sweet, right? So now when we go to our little example, which is in portfolio, I think. He's giving me a red bar. I'm not sure why. The floating certificate of deposit was assumed to have a constructor that took no arguments. So we'd still have to create that constructor. So now I got two constructors, and these are overloaded. Overloaded methods allow you to have two methods with the same name but different arguments. And then the question of which one is invoked is a function of what the argument's data types are. So if you pass in another certificate of deposit to the floating point certificate of deposit, it uses it in order to do a new construction. Set P will be C dot get P. If you don't pass in anything, it just uses the default values for the principal and the interest rate. So now, I think we're ready to go back to our little portfolio example, and we can see that the certificate of deposit can be used to construct the subclass by virtue of copying its properties. And now we don't have to worry about, let's say, trying to fool the compiler, because we created a specific class that would enable us to make new instances of the subclass from an instance of the superclass. And now things are working. Hurrah! What do you think of that? Pretty sweet, right? So let's recap. I can convert from subclasses to superclasses without casting, with wild abandon, at will as programmers. I cannot convert from superclasses to subclasses, but I can make new instances of subclasses from superclasses if I create, let's say, a fancy constructor, an extra method that allows me to take the properties of the superclasses and copy them. So you don't need subclassing to use the has-a relationship. That is to say, I could say Professor Lyon has a pen, but if I want to inherit properties from the pen and be a kind of pen, then I must have subclassing. That looks like Mike. Hey, come on in, Mike. No? I guess he's poking his head. He wants to see if I'm done. So we went over a little bit, but that's what I have for you today. Are there any questions? It's a good thing Mike came up, otherwise I'd keep going. All right, so I'm stopping.